Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider. You are watching Learn and Teach by Sir Ayaz. So I will continue my video session for past papers, and I was doing summer 2015 for 5070 and the variant is 22. I am done till A3, so I will continue from A4. This is a question. The flow chart shows some reactions of iron 3 sulfate FeSO4. So this is FeSO4. You can see if you heat it strongly, you are getting B, A, brown solid, B, colorless gas that turns acidified potassium magnate 7 colorless, C, colorless gas which has 40% by mass sulfur and 60% by mass oxygen. If you dissolve FeSO4 in water, you will get FeSO4 aqueous. FeSO4 aqueous on reaction with NaOH aqueous gives green PPTD, but on reaction with reagent X gives white PPTE. Okay, this is the first part. A. Iron 2 sulfate is heated strongly. Number 1, write the formula of gas B. Gas B. This is a gas which turns acidified potassium magnate colorless. There's only one gas we have in our syllabus, and it's SO2. So you write SO2. This is sulfur dioxide. Number 2, calculate the empirical formula of gas C. Name gas C. So first of all, we need to calculate the empirical formula of gas C. Let's see the information. It's a colorless gas which has 40% by mass sulfur and 60% by mass oxygen. S is 40%, oxygen is 60%. So in the first step, we will divide this by the AR of these elements. So sulfur, where is sulfur? Is sulfur. AR of sulfur is 32. What about oxygen? Here's oxygen. AR is 16. So for sulfur, we have 32. Oxygen, we have 16. 40 divided by 32, 1.25. What about oxygen? 60 divided by 16, 3.75. Now let's divide both the values by the smallest combining ratio, or the least number of moles, that is of sulfur. So we'll divide both the values by 1.25. So for sulfur, we will get 1. For what oxygen? 3.75 divided by 1.25. 3. So the empirical formula must be SO3. And it is sulfur trioxide. We call it sulfur trioxide. Next part. 2 moles of iron 2 sulfate decompose to form 1 mole of solid A and 1 mole of gas, 1 mole of gas C, 1 mole of gas B. So gas B, where's gas B? So here's gas B. Gas B is SO2. What about gas C? Gas C. Gas C is SO3. So they are asking us to deduce a formula of solid A. So if you'll write the equation for iron 2 sulfates FeSO4 on decomposition, it's producing 1 mole of gas B, which is SO2, 1 mole of gas C, SO3 plus what is left? They are saying brown solid. So brown solid must be a compound of Fe. It can't be the compound with sulfur. It must be with oxygen. It must be Fe2O3. Because in this the oxidation number changes. That is, it has increased the oxidation number of charge on Fe. So it must be Fe2O3. Even if you balance the equation by writing 2 before FeSO4, you will get SO2 plus SO3. It's count the number of sulfur atoms. 2, correct. Oxygen, 2 4s are 8. 3 plus 2, 5. 8 minus 5, 3. So it must be Fe2O3. Are you getting my point? Fe2O3 is left. That's why the formula of A must be Fe2O3. The other point is also true that it's of brown color. The reason is that Fe is carrying plus 3 charge here. So Fe2O3 must be the right answer. B. Write an ionic equation including state symbols for the formation of green precipitate D. Green precipitate D, where is this? Green precipitate D. So there must be a reaction between FeSO4 and NaOH. So we need to write the ionic equation. So when FeSO4 aqueous is reacted with NaOH aqueous, double displacement will take place. The partners will be exchanged. Na will join with SO4. Fe will join with OH. What about the formula? Splitting the formula between Na and SO4. SO4 carries -2 charge. Na is in group 1. Group 1 carries +1 charge. So I will write +1 for sodium. Ignore the charges. These subscripts will be exchanged, which means we'll get Na2SO4. So the one of the product must be Na2SO4 aqueous. It must be aqueous because all sulfates are soluble except besan ke laddu. Barium, calcium, and lead sulfate. These are not soluble. Other sulfates are soluble. Furthermore, salts of sodium group 1 metals are soluble. What about the next compound? Second compound. You have to place 2 here in order to balance the equation. So Fe will be joining with OH. What is the charge on Fe here? It's carrying +2 charge. OH must be carrying -1 charge. Ignore the charges. These subscripts will be exchanged. So we'll get FeOH whole twice. Must be twice. And it must be in the solid state because the green precipitate form, it's insoluble in excess. Now let's write the ionic equation. That was the equation. FeSO4 aqueous plus NaOH 2NaOH aqueous. One of the product is FeOH whole twice solid plus Na2SO4 aqueous. Now remember the rule. split up or open up the compounds with aqueous. You can't open or split up the other compounds with the state symbols S, L, or G. So FeSO4 can be written like this: Fe plus 2 aqueous plus SO4 minus 2 aqueous plus 2Na plus aqueous plus 2OH minus aqueous. What about the product side? On the product side, leave FeOH whole twice as it is and open up this Na2SO4, which means 2 moles of Na plus ion, and again aqueous plus 1 mole of SO4 minus 2 aqueous. Cancel the spectator ion, that is common ions on both sides of the equation, Na plus, SO4 minus 2. So finally, we'll be left with Fe plus 2 aqueous plus 2OH minus aqueous gives FeOH whole twice solid. C suggests the name of reagent X and give the formula for the white precipitate E. So you are getting white precipitate. So X must be barium nitrate or any soluble salt of barium. So you can write either barium nitrate or barium chloride. This one is also one of the soluble salts. On reaction with iron 2 sulfate, you'll get white PPT of barium sulfate. So formula for barium, formula for precipitate E must be BaSO4. Barium sulfate, Ba. Sulfate ion carries minus 2 charge, barium carries plus 2 charge. Ignore their charges, same number. These subscript will be exchanged and you'll get BaSO4. Moving to the next question. This question is about electrolysis. Electrolysis is often used in the extraction and purification of elements. A, magnesium is manufactured by the electrolysis of molten magnesium chloride. Write equations for the two electrode reactions that occur during this electrolysis. So, the attraction. So, we have molten magnesium chloride. So, at cathode, there must be Mg plus 2 ion gaining electron. So, you write Mg plus 2 electrons gives Mg. What about anode? At anode, it must be loss of electron by the chloride ion. Cl minus gives Cl2. Chlorine exists in the diatomic state. So I will write Cl2 plus electron. Now balance it. So you have to write 2 here and 2 before. B, copper can be purified using the electrolysis of aqueous copper 2 sulfate. What is used as the anode? Positive electrode. So during the purification of copper, using the electrolysis of aqueous copper 2 sulfate, we must have copper electrodes. Both are copper electrodes. So one must be impure, another must be pure. Impure must be at anode. So you write impure copper here. And cathode must be of pure copper. So you write pure copper here. What about number C? Chlorine can be made by the electrolysis of concentrated aqueous sodium chloride. The overall process can be represented by the following equation. Here's the equation: 2NaCl aqueous plus 2H2 liquid gives 2NaOH aqueous plus Cl2 gas plus H2 gas. 55 dm cube of 3.5 mole per dm cube aqueous sodium chloride is electrolyzed. What is the maximum volume of chlorine that can be found measured at room temperature and pressure? Now we have the information of sodium chloride. Information for this is given. They are asking us to calculate the volume of chlorine. So we must have the moles of chlorine. In order to get the moles of chlorine, we must have the moles of sodium hydroxide. Information is given, that is 55 dm cube, 3.5 mole per dm cube. So you can write moles of NaOH. So 1 dm cube contains 3.5 moles. Therefore, 55 dm cube contains X moles. Do the crossing, so you'll get X equal to 3.5 multiplied by 55. So what you will get? 3.5 multiplied by 55. 192.5. 192.5 moles. You have the moles of sodium chloride. Look at the relation. This is the relation. NaCl, Cl2. You have 2 moles of sodium chloride gives 1 mole of Cl2. Therefore, 192.5 moles gives X moles of Cl2. So you write X. 2X is equal to 192.5, or X equal to 192.5 divided by 2. One 92.5 divided by 2, 96.25. 96.25. These are the moles of chlorine. Now at RTV, you know that what's the last point? What's the maximum volume of chlorine that can be found measured at room temperature pressure? We know that at room temperature and pressure, 1 mole of gas occupies 24 dm cube. So 96.25 must be multiplied by 24. 96.25 multiplied by 24. 2310. This will be the volume of chlorine produced. Moving to next part. Section B. Answer all questions from this section in the spaces provided. The total mark for this section is 30. A4-B6 ammonium carbonate NH4 whole plus CO3 is a white solid that is a component of smelling salts. It decomposes when it's heated. Here's the decomposition reaction. NH4 whole plus CO3 solid gives 2NH3 gas plus H2 gas plus CO2 gas. A sample of ammonium carbonate is heated strongly until it all decomposes. Suggest what would you observe during the experiment. Now it's a white solid. So you'll straight away you can write white solid disappears. White solid disappears. What else you can write? Or you can even write, they are saying as a component of smelling salts, and you are getting ammonia gas. So ammonia gas is pungent smell. So you can even write pungent smell. Or for water is produced in the gas state, so must be condensation happening here. Due to this reason, condensation, you are getting H2O gas. Or you can even write for carbon dioxide, that is colorless droplets. Colorless droplets. These are of carbon dioxide. Number B. Describe how you would show that both ammonia and carbon dioxide are found in this decomposition reaction. Is simply go for the test for ammonia gas. Write the test for ammonia. Which is turns moist. Remember, you have to write moist or damp. You can't only write litmus paper. You have to write moist or damp, litmus paper blue. It can only turn moist or damp litmus paper because in this they produce OH negative ion. All the changes or reaction happening are due to the production of OH negative ion. The solution. You can even write the test with glass rod or test with glass rod. Glass rod is dipped from concentrated HCl, concentrated hydrochloric acid, concentrated hydrochloric acid. You get white smoke. Test for carbon dioxide. Lime water. Turns lime water milky. Test with lime water. Turns milky or goes white. White or milky. You can even write white precipitate for this. Next part, C, ammonium carbonate is soluble in water, but zinc carbonate is insoluble in water. Describe how you would prepare a sample of pure dry zinc carbonate using a solution of ammonium carbonate. Now you want to make sodium zinc carbonate from ammonium carbonate. So you have to start with the soluble compound of zinc. Start in the start you write add soluble salt of zinc. Like you can take zinc chloride, zinc nitrate, or zinc nitrate. You can even take sulfate because sulfate is also soluble. Remember, बेसन के लड्डू, barium, calcium, and lead, these are insoluble. So an insoluble salt of this. Then in the next step, what do you have to do? So you must have one of the reactant in excess. So you have to filter. And the salt produced, it's a soluble one. Zinc carbonate. It's not soluble. All carbonates are insoluble. All carbonates are insoluble. Except group 1 are insoluble. Except group 1 or ammonium. Group 1 like except sodium, potassium, or ammonium. Don't write group 1, just write these. So it must be insoluble. So you have the residue, wash the residue with distilled water, not with tap water. Wash the residue with distilled water. Even you can write deionized water, not with tap water. So you are done with this. Any description of drying? So we will write dry the residue. Dry the residue in air. Part D, excess ammonium carbonate reacts with phosphoric acid H3PO4. Consider an equation for this reaction. Ammonium carbonate reacting with acid. So I will write ammonium carbonate is NH4 whole twice CO3 because CO3 carries -2 charge. So phosphoric acid is H3PO4. This reaction between carbonate and acid will get three products. One of the product must be carbon dioxide, CO2. The other product must be water, H2O. And the last one is the salt, which is formed between ammonium ion and PO4. So ammonium ion, it carries +1 charge. Phosphate ion, it carries -3 charge. Ignore the charges. These subscripts will be exchanged. So we get NH4 whole thrice PO4. Let's balance the equation. So if I will write 3 before ammonium carbonate, so this becomes 2 NH4 whole thrice PO4. What about CO2? CO2 becomes 3 because there's 3 moles before ammonium carbonate, so I have to write 3 here. What about hydrogen? 2 4s are 8. 2 4s are 8 and 8 3s are 20. 24. Yeah, 8 3s are 24 and plus 3. So we'll have 4 5 6 7. 27. Hydrogen must be 27. There must be 27 atoms of hydrogen on the right hand side. So we have 3 4s are 12. 12 2s are 24. Something is missing here. NH4 whole twice. 4 2s are 8. 8 3s are is 24. 24 plus 3 is 27. Yeah, right. It's balanced here. 4 3s are 12. 12 2s are 24. 24. So we need to balance phosphoric acid also. So I will place 2 before phosphoric acid and 3 before H2O. Now this reaction looks balanced to me. Let's count the atoms, each atoms here. In the end, nitrogen, 2 3s are 6. Product size, 2 3s are 6. It's balanced. Hydrogen, 4 2s are 8. 8 3s are 24. 24 plus 2 3s are 6. 24 plus 6 is 30. On the product side, 3 4s are 12. 12 2s are 24. 24 plus 3 2s are 6. It's balanced. So hydrogen is also balanced. What about carbon? 3 moles of carbon on the reactant side, product side. Again, it's balanced. So oxygen, 3 3s are 9. And 9 plus for oxygen. 2 4s are 8. 8. 8 plus 9 must be 17. On the product side, it must be 17. 2 4s are 8 plus 3 2s are 6 plus 3. 6 plus 3 is 9. 9 plus 8 is 17. Now oxygen is also balanced. What about phosphorus? 2 moles? Yeah, phosphorus is balanced. So the final equation, it's balanced. So we have 3 NH4 whole twice CO3 plus 2 moles of H3PO4 gives 2 moles of NH4 whole thrice PO4 plus 3 moles of CO2 plus 3 moles of H2O. This equation is balanced. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.